So the major biological functions of pantothenic acid are: it's a precursor for coenzyme A, which affects the metabolic pathway. It helps with fatty acid synthesis, as well as energy metabolism.
I'm Vinny. The three most pantothenic acid-dense foods are 3 ounces of chicken breast, which equals to 1.2 milligrams, 1 ounce of sunflower seeds, which equals to 2.4 milligrams, and 1 medium avocado, which equals to 2 milligrams. But surprisingly, olive oil does not have pantothenic acid.
Hi, I'm Alex. The RDA value for pantothenic acid in adults is 5 milligrams per day. In order to achieve this RDA value, someone can consume 6 ounces of chicken breast, which is roughly 2.4 milligrams, and 1 medium avocado, which is roughly 2 milligrams, together to get around 5 milligrams of pantothenic acid. And a nice meal. Fun fact, the suffix panto in pantothenic acid literally means everywhere, as in you can find pantothenic acid in almost all food sources. Wow! The RDA value for pantothenic acid is predictably higher for pregnant women because they need to help support the nutrients for the fetus. So the RDA value is 7 milligrams as opposed to the regular 5 milligrams for everyone else.
So the major reasons for being deficient in pantothenic acid is a poor diet. Obviously, if you're not consuming enough food with pantothenic acid in it, you're not going to have an adequate amount of it. And also there's a certain medical condition called pantothenic kinases associated neurodegeneration, where you cannot metabolize the pantothenic acid as well. And thirdly, alcoholism is a major reason of pantothenic acid deficiency. And the effects of being deficient in pantothenic acid could be fatigue, neurological problems, and digestive issues, such as a stomach ache or diarrhea.
Pantothenic acid is generally not toxic, and there's no really established upper limit. However, it can be toxic if you exceed taking over 10,000 milligrams per day, which can cause an upset stomach or diarrhea. But since it's water soluble, it can be disposed of through the kidneys.
Hey, I'm Tyler, and these are the interactions that pantothenic acid has. It interacts with B2, biotin, folic acid, and zinc, because altogether they act as a precursor to coenzyme A. So we know there's pantothenic acid, but did you know it also has alternate forms? So first, let's go over this one. This is what we call dexpanthenol, which is our typical pantothenic acid. But if we slightly change it, it can have another form. This would be sodium pantothenate. The main difference here that you want to look at is how there's a sodium here instead of an alcohol. Likewise, over here, for calcium pantothenate, instead of the sodium, we instead have the calcium. And finally, for pantothenine, it seems like we almost have 2 dexpanthenols, but instead of their typical alcohol endings, they instead have 2 sulfurs that bind to each other. These are, as far as we know, the main alternate forms of pantothenic acid.
Now for a brief history lesson on the history of pantothenic acid. Pantothenic acid was discovered by Roger J. Williams. What a good-looking guy. Roger Williams served as the president of the American Chemical Society at some point. He discovered pantothenic acid when he served as faculty at the University of Oregon during his 12 years there. He was only 40 years old when he discovered it. I don't know if I'm going to be doing that when I'm 40.
Pantothenic acid as an NSAID. What is an NSAID? Well, an NSAID is a non-steroidal anti-inflammatory drug. Now, this could be really awesome because if the trials that are already being gone through prove more results, then it can be an alternative application to something such as hydrocortisone, which is what I feel like a lot of people use when they have a minor cut or a burn. Alright, so what does this mean for pantothenic acid's use in dermatology? Since dermatology is a study of the skin, there's a correlation between that and pantothenic acid. Now, with more testing, even though there are already trials going through with its most well-known form, the xanthanol, it could possibly be used in a mild to moderate childhood ectopic dermatitis therapy. And furthermore, it can be used to manage skin and mucous membrane side effects that typically occur in acne treatments. Now, let's get into dyslipidemia. This is an imbalance of lipids. Now, in these trials, instead of the xanthanol, what we instead used was its alternative form. If you remember, pantothenic. Now, pantothenic was clinically tested, and the outcome was that through its usage, this alternative form lowered cardiovascular disease risks markers in low to moderate risk participants. And just to know what these risk markers were, we see that they were for LDLs, HDLs, and total cholesterol. Wow, isn't that so cool to think of how pantothenic acid can be used in so many various treatments?